Bismillahirrahmanirrahim. Assalamu alaikum wa rahmatullahi wa barakatuh, guys. We have had a discussion last two classes about several things, and we are still on our first chapter of the book, on also discussing the first few concepts. Already you have seen some examples of some code related to threads, multi-threading, concurrency applications. However, I have already created an example assignment for you guys, and this is going to be your assignment that you have to try to do. And of course, I also gave you this tutorial to try, and as I told you guys, there is no need for you to submit if you already are familiar with these things. And if you are not familiar, you should try to see if you are able to do this kind of basic programs using Java programming. The purpose is to help you finish up with the assignment. So your assignment is divided into assignment 1, assignment 2, both of which are part of your coursework, of course, and your final exam, which is 60%. So the first 40% comes from your assignment 1 and assignment 2. Assignment 1 is 20%, assignment 2 is 20%. Now assignment 1 is going to be programming, so this example tutorial 1 that you have done here is going to help you a little bit on bringing about, refreshing your mind about the Java that you have done in previous semesters. And here you have your assignment 1, which is going to require you to have a little bit extensive coding, because you have little bit of object-oriented programming background to write these things. Now, although they are simple, the coding itself is a little bit lengthy, because it has a few classes here. It has a customer class, it has a bank account class, and the attributes are given to you. And after you create the attributes, you also have to create the constructors, the default constructors, overloader constructors, getters and setters, to string methods. So these things are what appears in every single class. So you have to do those things. Although they are simple, there's a lot of coding. And also you have to create another class called transaction class, and this is where you're going to simulate what you have studied in the class about creating threads. And you haven't really had such a big practice yet on threads. In the next weeks, our classes will be on highly on threads. We will try to have a huge discussion where we could run an example multi-threading sessions. So what you have seen so far is just an example view of how classes look like, how threads are created, how they appear, how it is coded in Java, but you haven't really tried yourself to create those classes. But your assignment requires you to do that, guys. So please go back to the videos that we have done earlier, and pause the videos and try to create those programs yourself, and see if you are able to create and do that runnable objects, and also extend implement those runnable, and try some of these things around to get some idea here. So this example lies around descriptions giving you exactly what you need to do. So like that, you have to create a transaction class that implements runnable, so you know what it means. And also inside there, what you need to do is also mentioned. That specific transaction class will have these objects. So instead of giving you the scenario of the activity, it has given you specific steps for you to do. So that's going to be easier for you. You just follow the step by step, and you don't have to be in the WAG. You will be clear. And of course, you have to do all these things in a Java program, and show the output, sample output, onto your Microsoft Word pages when you are creating your submission. Have your cover page and everything according to the college requirements. And also you have to make sure you show the codes at the end of the paper as appendix. All the codes you have to copy paste into the Microsoft Word when you're submitting. And you can also submit the projects you have done using Java as a zip file in addition to those things, so you can put all of them into one zip file. So I have given here descriptions of how you should be doing your assignment. In the transaction class, what are the methods you need to create, and also in the transaction class, where does the run method exist, because you are implementing this runnable method, this runnable interface. You need to have run method. If you remember correctly, when we discussed about threads, we said threads need runnable objects, and here we are making transactions as runnable objects. So you have to have the run method. And if you go back and watch videos, you will see what I'm talking about. So I want you to work on those things immediately when you get this assignment. Try to create the initial parts where you can finish them. And probably you will be stuck or taking most of the time on this last section, which is 7 and 8, where you actually have to simulate uh, a withdrawal and a deposit into a customer account simultaneously. And there you will try to see the issue, and also you try to solve it. So in database terminologies, this is a very famous activity. It's called lost update problem. So in the lost update problem, one of the events that happens is there is a customer who has a bank account. In this bank account, one of the action is a $10 withdrawal, and this $10 withdrawal of course brings down the customer's balance. So it is on you of course to give an initial balance. Here you have to give an initial balance when you're creating the customer and the bank account. So a $10 is taken from the customer account. Let's say if there is if there is 900 rupiah, you have taken $10. Now you have 890 rupiah, and then there is another deposit of 100 to the customer's account, which happens to be happening at the same time. If they are not coordinate well, then there will be some issues there. So you can try to run this program using threads. First you can run it without threads and see how it goes. Then you can create threads, and then you can try to create the program by solving the problem, because the initial problem you will see is it doesn't add up. For example, 990 is let me try to show you here in the notepad. For example, if you had 900 in your account and you have withdrawn let's say you have two transactions, okay, so 900 is the balance. Let's say this is transaction 1, this is the balance is 900. Then you have transaction 1, okay, and then you have transaction 2, okay. So both of them first reads your balance. So what they do is they read balance, and then the balance is read as 900, and then this transaction withdraws a $10. So it takes $10, therefore your balance becomes 890. Here the balance remains like this. At the same time, in the transaction 2 there is a deposit, so there is no withdrawal here. The balance remains 900, and then there is a deposit. In the deposit case, the transaction 1 is not doing anything because it was withdrawing. Transaction 2 is depositing $100, for example 100 rupiah, if you make that 900 as rupiah. And what happens is the balance is now actually 900 plus 100 according to transaction 2, but according to transaction 1 it is 890. So the balance here, if you analyze now, the balance is 890 versus 1000. Yeah, so it deposits 100, making the account balance is 1000, and 890 versus 1000. If you write your transaction, if you save this transaction, which one should you save? Should you save transaction 1 or transaction 2? So how do you make sure they don't overlap and they actually don't bring out an incorrect outcome? Because if you write the balance as 890, whatever happened to that $100 that you deposited is gone. If you forget about that $10 withdrawal and you just deposited 100, then you are losing that $10. Of course, this is not about losing $10 or losing $100. It's about making it accurate. What if the withdrawal was $800, you know, and that update may not be lost as well. So generally speaking, if you run simultaneous actions on a transaction on a single customer account, there may be problems, and it will be clear to you when you try to do this without threads and with threads. So you have to create two threads to carry out these transactions simultaneously, and then this is the part where the most of the marks will be given, because this is where you're going to apply your concurrency techniques and learned skills to make those transactions run in a manner that the two transactions also are able to run simultaneously, but at the same time they are not going to bring about inconsistent state. They are going to bring about a consistent output. That's why the marks even here, only the last part itself is 30 marks, everything else is lower than that. Then individual marks are given to those questions also, they are okay there. So even if you are not able to finish 8, still you get good marks there, but still you have to make sure you finish this in order to get the 30 marks here, you know. That's also quite a lot of marks. So remember, you have to finish this part as well. Now how do you do this? You learn these things by watching the videos that I have done about transactions, about example classes you created, and also multi-threading and concurrency control application we have created earlier as a simple output. And of course in week 2 we are going to learn more about how we can synchronize threads across and also how we can use yield methods, how we can use sleep methods, all those things in the thread class, which is going to give you more exposure into how the thread application works and are controlled and also joined, and that kind of communication between threads. Thank you very much. That's your assignment details. Okay, we are not done here in the video yet. That's for the assignment. Please follow up, and you should wait for the college to give you the assignment in a formal format. Okay, now last session we were talking about this example here where we said whenever a thread is running, it has all these states. We have created a thread and the thread is ready to execute, and if you yield it, it will wait for a specific number of times until it's timed out, and then it will start running again. And also it may also go into this stage where it actually a join method is executed on it, and then what will happen is it will wait for the joined method to finish, and then it will run again. If you ask it to sleep, it will wait until the time is out for sleeping, and then it will go back. And of course, if you make it wait for x number of times, it will wait until notified, so these are effectively blocking stages. And then of course the run is the finish. And we don't see the interrupted method here, interruption. You can actually interrupt a sleepy method, or you can even interrupt a waity method. So those things you'll come across later on, but for now you have to remember this diagram, because in the exam if you see this diagram, you must be able to label it accordingly and accurately. Okay, so even for these theory concepts, most important part is in the exam you should be able to answer them. Okay, so here we are in the chapter 1. We have finished 1.1 section where we are talking about using concurrency constructs, and now we will have a look at the second area, which is objects and concurrency, and we will in this lecture we will finish up in this class with all these things and ending chapter 1. Therefore in the next week we will have a lot of practical sessions where we can deploy more details about threads and multi-threading and concurrency control. Okay, so I told you guys there's a whole extra theory also in this module. So here is an example of theoretical concepts which you have to remember and learn. You could learn these things by noting them down in your own notes, by taking your own notes, or creating some sorts of mind maps. Okay, you don't have to memorize these things. So if you guys anyway you can learn these things, learn this point form, and I have created them as slides, which means if the question says what are the common types of concurrent applications, or give example of concurrent applications, then you can give these examples in the exam, even if it is not about details. If the question says explain and show example concurrent applications, then it's about describing it. So basically your assignment 2 is going to have these kind of example discussions, where the first part of your studies, first 50% of the lectures will be covered in assignment 2, which will be given to you guys at the end of week 3. There week 1, week 2, week 3 concepts will be covered, so you have to answer those things in the assignment 2. Then in the final exam we will only cover those topics that start on week 3 until end of the semester. Right, so what are web services? So web services are also example of an application that uses concurrent applications. Why? And these are example details of why they do that. Most socket web applications or web services are multi-threaded, and the reason is this ensures that new incoming connections do not need to wait out completion of other tasks. This minimizes the service latencies and improve reliability. So there may be cases where the question actually might be specific why are web services using concurrency, then you might explain this. So you don't always have to expect that the question will be list out the common types of concurrent application. It may actually be about one of the concurrent applications. So please try to remember these things. Okay, so concurrent applications are also seen on web applications, on number crunching, where you have to actually do a lot of calculation, and thereby you are using more efficient use of your CPUs. If you have more CPUs, so you can parallelize them basically, so that actually increases the throughput by exploiting parallelism. And common types of concurrent applications also include I/O processing applications, or I/O processing itself in operating systems, where I/O processing also happens simultaneously while other things are going on. And Concurrent programs can use time otherwise wasted waiting for slow IO. This also increases motion use of computer resources. Simulations, when you are doing simulations, also a lot of things can be run simultaneously, and concurrent programs can use simultaneous can simulate physical objects with independent autonomous behaviors that are hard to capture in purely sequential programs. So of course you can't deploy them in sequential programs. It has to be deployed in a sequential manner. Even if it is a simulation, things have to happen simultaneously. If it is designed to show certain actions, that should happen at the same time. And that also brings us into this idea of GUI applications, because graphical applications that you have seen, for example, the example of the particle application, where you are moving a particle simultaneously. So if you are doing something simultaneously on the interface, and many a times, like reading a file at the same time loading a picture, or for example listening for an event or something like that, these are example things that should happen on multiple threads, separate threads. It's not about having a lot of threads, it's about running efficiently with enough number of threads and not with a single thread. So GUI based applications also require threads in order to be responsive even during time consuming actions. That's what it says. So even if one task is taking a little time, for example uploading something, or for example downloading something, still you can do other things because you have more threads to work on. Right. And that also includes, although we are not going to go into the definitions, embedded systems, component-based softwares, and mobile applications and mobile systems also include a lot of concurrent activities actually. Okay, so remember, these are example theoretical questions that I expect you to answer. What do we understand by the term concurrency? You have to go through these things, and these points, for example, in the exam where the marks are given, they actually focus on these slides. So don't go for Google answers, or don't go for answers that include things that you find on Wikipedia. Stick to these slides. What is the difference between processes and threads? Okay, what is the process and thread in Java? What is a scheduler? How many threads does a Java program have at least? So at least main thread is there. And then you can create an infinite number of threads, but of course threads have to be limited, otherwise the application will not scale well. So it's not really about creating so many threads either. Okay, so another aspect of it is about design process. When you are designing multi-threaded applications or concurrent softwares, when you're designing, creating them, there are some concerns that arises. Okay, so some of the important things when you design applications is there are two basic things that you have to balance, and one of them is safety, the other one is liveness. So these terminologies, a lot of terminologies, so please try to understand what they mean. Safety, for example, nothing bad ever happens to an object. Safety failures lead to unintended behavior at runtime. So if you actually are not able to handle, your goal is nothing bad ever happens to an object. That's your goal. If you want to achieve that, then it will impact other features. For example, safety failures lead to unintended behavior at runtime. If you don't have enough safety practices handled in the application, of course it leads to unintended behaviors. For example, if you have an array and you are getting the data into the item, loading the data into the item, and the number of items that you have loaded is less than the number of slots of arrays you have created, then there will be null issues. So then later on your application may have some issues. It's a very crude example, but you get the point. So things just start going wrong. Okay, so basically a lot of things will go wrong if the safety practices are mishandled or not handled properly. That is one of the design factors that has to be kept in mind when designing applications, especially for concurrency. Liveness, on the other hand, means something eventually happens within an activity. Meaning you can't avoid, by creating so much safety borderlines. Liveness failures lead to no behavior. Lead to no behavior. Things just stop running. Okay, no behavior. They don't show any behavior. They get stuck. So sadly enough, some of the easiest things you can do to improve liveness properties can destroy safety properties. They are kind of like oxymoronic, because you are saying in one hand you need more safety, on the other hand you have to make sure that they respond accurately. Okay, so uh, getting them both right can be challenging. Now, of course, this is a theoretical concept. You will only understand when you try to do something, an application, and at this level, as a theoretical model, we will not be able to grasp the importance of these terminologies without going into whole details of how applications are designed. Okay, some of the quality design concerns related to designs include, for example, the reusability of your system, the utility of objects and classes across multiple contexts. So that is also an important aspect of design. Now, performance, again, the extent to which activities execute soon and quickly in terms of performance. And why does application fails to make progress? Why is an concurrent application stuck, or in a specific case failed or unable to make progress? It may be for one of those reasons. For example, there might be a lock. So again, this is a question, you have to answer these questions. What are the reasons an application or a concurrent application may fail to make progress? And then you have to answer these kind of questions, like example, lock-in, waiting, input, or IO, CPU contention. Okay, so if you read through them, they are self-explanatory. That's an example way of how you have to learn these kind of things. Okay, all right. If you create an application, how do you measure the performance of application? So you create an application, or even think of any kind of abstract concept. Performance itself can be categorized using criterias. So how do you decide that? Number one, throughput, for example. Even in a networking terminology, or in a storage perspective, they always talk about these kind of factors. Performance is related to these factors. Throughput, the number of operations performed per unit time. If you are given x number of seconds or minutes, number of operations performed in this period. And of course, this is usually recorded as the time taken to perform a single operation. That's what throughput really is labeled as. And then you can find other definitions also of this. They ultimately mean the same thing. Latency, the time elapsed between issuing a message via, for example, a mouse click, method invocation, or incoming socket connection. So, and serving it. So for example, someone has requested for data, someone has clicked the mouse, and the time it takes for you to respond, those are latency, right? The delays until something happens, that is what latency means. So that also is used when you are describing performance of a system, of an application, or whatever it is you're measuring performance for. Capacity is another factor you will use when you are measuring performance, the number of simultaneous activities that can be supported for a given target. Minimum throughput or maximum latency is affected by capacity. So given target, minimum throughput or maximum latency. So minimum throughput or maximum latency is affected when you increase and decrease capacity. Okay. Efficiency, how fast or how efficient is your application, meaning throughput divided by the amount of computational resources needed to obtain this throughput. Scalability, very important terminology, especially you will hear this terminology nowadays when you apply to the cloud, because the cloud concepts of having a lot of grow slowly, or meaning being a scalable solution means pay per type of services. Like if you're taking a SaaS model, or for example a PaaS model on the cloud, you might have a huge scalability because it is based on the cloud. Why is that? Because you are able to add, edit, and remove performance characteristics such as CPU, memory, and devices easily into the setup in the cloud. So even you are measuring performance in a local sense, still scalability is one of the factors you will measure. And the opposite is degradation. If you don't increase the resources, how does the degradation in the performance is measured? Okay, without adding extra resources, you are measuring the degradation given current circumstances. Alright, and then this is also one of the last chapters in the last sections in this chapter, which is talking about before after patterns, meaning many things that usually have to be done before something happens, and what you do after that. And one of the very common aspect of this is actually about threads. For example, when you are creating multiple multi-threaded applications or concurrent applications, you will always remember this word called synchronized. So synchronized method requires a lock before executing the code inside the method and releases the lock after the method otherwise completes. Okay, so here is again another definition of liveness. Something eventually happens within an activity. So liveness filia leads to, yeah, in reality what you see here is a slide that has been edited. So this shouldn't exist here. Let me just delete it. Okay, don't worry about that. It's a slide copy paste issue. So before and after really refers to things that you do before and after an activity or an event. Yeah, especially for example in this case we are talking about concurrency control. Right, look at this behavior for example, where when we talk about uh, before and after activities, you will immediately understand two things now. One is abstraction. Okay, so you're forcing behavior upon your classes, upon your child classes, which we will also have a look at. Abstract classes. When you have abstract classes and your child classes extend those abstract classes, they will have to implement those abstract classes before they could continue or create their own functionality. So that is an example of something that relates to behavior, where a class is required to do implementation of the abstract methods before it can implement its own methods. And in this case here is an example of something about try catch, for example exception handling. So again, if a method generates an error or an exception, you have to handle that. You have to write those constructs before your application gets compiled. And they are especially in a exception handling perspective, we have this concept of try catch block, meaning you have to handle the exceptions before your method gets executed, and certain behaviors in the exception handling forces the compiler to take action before you can compile the program even. And after you have implemented the catching of those exceptions, still there is a separate section called finally, which we do, which means things that will happen after exception occurs. So if you have a program in that you are implementing from your abstract method, it might actually force some behavior that you have to do something before that activity, and then the after activity might usually align in your section of the finally block, which is even if there is an error, finally you do this. For example, before you connect to the database, you need to have a database connections. You need to have those username, password, and a persistent connection to the database. And once you have that information, you might go to the database and collect the result sets, and you might actually do processing. However, after you are done, you will have to close the applications, and you will have to close the result sets and database connection. Okay, that's an example of behavior we could study, and we will actually have a look at the concept of abstraction, because that is also an interesting phenomenon which we can study as later on we will come across the implementation of it. Here is an example of what does it mean to have abstraction. Just to give you an idea, abstraction means generality, generalization. Like for example, in this case, you have two classes that inherit from the class geometric object. And if you think about it, inheritance is all about dividing that into parent class and child classes by taking out all common attributes into the parent class. In this case, we did this because otherwise all these things will appear in this class as well as this class, and also in all the future other shapes you are going to create, you are going to have these classes. Therefore, it's a very good idea to divide all the main common attributes into a parent class and then be more specific in the child classes. So later on, if you create a square, for example, or a rectangle or a triangle, for example, they'll still be able to have many of these parameters which are going to be the same. For example, they will have a color. If you have a let's say a two-dimensional shape, it will have a color, and then it will be filled, and there must be a date where this shape was created, for example. And then you might have uh, a method to fill it with some color, get its color, set its color, check whether it is filled or not, or set it as filled or not, get when it was created, because remember this minus sign here refers to private variables. Therefore you need plus functions or public functions in order to derive them. And of course these example of constructor and overload constructor shown here. And then you have other methods such as get area and get perimeter. Now this is an example of a class. Abstraction means this class sphere does not represent any shape. That's what abstraction means. It's too general. You can't say, oh, I am a geometric object. No. What kind of object are you? Are you a circle? Are you a rectangle? Are you a triangle? Are you a square? You know. So you can't say I am a generic, or here is a geometric object. That's too general. So abstraction means general characteristics are always picked up into a common class, and then you divide your classes by enforcing this behavior on your child classes. If the circle is going to extend my geometry class, it will be required, for example, it must implement these methods, which are called get area and get perimeter. Get area and get perimeter. So this one and anyone else also must implement these classes because they are declared as abstract. Okay, and that's why they are italicized. Okay, they are italicized. Okay, and in terms of abstraction, there is something related to us when we are doing in the initial class. We did some example of an interface, and that is this runnable interface. We have the runnable interface which we pass into the implementation of the classes that wants to have the multi-threading enabled, and then we use those objects to pass them into our task classes, our thread classes. So if you want to implement an abstraction, then you could use two different concepts. One is you can use abstract classes, or the other is you can use interfaces. There's a difference in the way you implement them, which we will have a look at during this class itself. So interfaces represent, for example, interfaces represent variables that are public, static, final. If there is any variable in it, it will be public, static, final. In the abstract classes, there is no restriction about the variables. If you have constructors, then abstract classes are invoked by subclass through constructor chaining. An abstract class cannot be instantiated using a new operator. So you can't create a shape using geometric shape. It's not a shape. You have to create using one of these bottom classes, child classes. Now interfaces on the other hand does not have any constructor. You can't directly implement them in an object. You have to implement them. You can't extend them. Interface cannot be initialized using a new operator. You can't put an object inside it. Okay, so now you may remember you may remember that the runnable class was an interface, but we put something inside it, and then we are saying interfaces cannot be instantiated using the new operator. This means creating new using the constructor of that class, not making another variable and assigning it into interfaces, which is a different concept. So here is what you will use if you want to generally extend a class, and at the same time if you want to implement some interfaces. Also, this is a scenario where if you want to inherit from multiple classes, you can actually convert the other classes into interfaces. And again, these aspects might be a little tough for you to understand for now, but we will have a look at what is the meaning of interfaces and what's also the meaning of abstractions before we close this class, and that will give us some idea about doing some little practice as well on the practical side. So we will of course talk about here in terms of how we are going to create these example abstract classes and how we can enforce behavior on childs, and we are going to see how we can use abstractions and interfaces comparison. That will be the practical aspect of what we do, and so there's a lot of theory there as well. You have to remember to answer them. And now next week our target will be to do a lot of coding to learn more about this concept of thread safe Java programs, and that is in order to prepare you for your assignment 1. And once you are done with those systems, those example programs, you can do your assignment 1 and submit easily. Even now you can do all the questions up to question number 8 actually. Okay guys, so thank you very much for watching. That's all for this session. We will come back online and discuss online what we are left with for tonight's class. Thank you very much.